Let's take a look at how these quadratics, or how we can set them up and what the heck we can do with them. Okay, so example 1. Susie has 3,000 feet of fencing available to enclose a rectangular field. What are the dimensions that will yield the maximum area, and then what is the actual maximum area? So for a lot of these application problems, it helps if you can kind of draw it out. So then you can see what you're trying to do. So it's what kind of a field? Rectangular. So just draw a rectangle. Doesn't matter if it's a wide, if it's tall, diagonal, however you want to draw it. So I mean, if just you choose. But you're also going to want to give it some dimensions. So personally for me, anything that goes left and right, that's an X. If it goes up and down, that's a Y. Because it didn't tell me how wide it was or how tall it is, so I don't know actual numbers. So you have to stick in letters for variables. What you do know is that you had 3,000 feet to go all the way around. Well, when you go all the way around a shape, that means you now have the perimeter. So you know the perimeter is 3,000. So if you actually used the dimensions with this to find the perimeter, 2x plus 2y is equal to 3,000. So with these problems, you're going to set up an equation like this that goes with the number that they gave you. But then you're going to set up a second equation. So with these things, you're typically going to have two equations you're using. So what's the second equation? Well, what thing are they talking about? What do they want the maximum of? Well, they want the maximum area. So that means you need an area equation with this shape. So your area, if you did the formula for the area of a rectangle, base times height, that would be xy. Well, your area is now in terms of two variables. It's in terms of x, and it's also in terms of y. You don't want that. You want either all x's or all y's. And it doesn't matter. You get to choose. I like to try to eliminate the y's, but you don't have to. You can eliminate x's if you want. So where do you do that? Well, that's going to come from the equation that you set up in the beginning. You can take this equation and solve for either x or y. I'm going to solve for y. So that'd be 1,500 minus x. And now that I know what y equals, I can substitute it into the area equation. So 1,500 minus x. So I want the max of this. Well, what kind of a function is that? Well, that's quadratic. Well, that's just like what I was doing up here. I was finding max and mins of a quadratic. So I'm essentially looking for the vertex. Like what's the actual maximum, and then where did it occur? So you have two different ways. You can either go off of the x-intercepts, or you can use that negative b over 2a. Now this, the way it's set up, it's factored. So I know my x-intercepts pretty well. That would be 0 and 1,500. Well, what number is right in between 0 and 1,500? 750. So your max occurs when x is equal to 750 and the dimensions are feet. Well, it wants to know the actual dimensions, so it wants to know x and y. So if x is 750, if you plug that back in, y also comes out to 750, so you really have a square. But it also wants to know what is the actual area. Well, to get that, you have two choices. You can either plug it back into your area equation, With the x's, we're just do base times height. So 750 times 750. So 562,500 feet squared. Okay, let me stop the video here and we'll continue with another example that's kind of similar.